Yeah, we're looking at the second year Stats and Mechanics textbook, and we're on exercise 4D, which is on moments and focusing on the centre of mass. So for question 6, so this is an exam question, which is quite good because it means we know how many marks each bit's worth. So we've got a seesaw. We've got Sophia and Roshan sat on the seesaw. So let's do our own sketch of this as we're going through it. Right, so there's my seesaw. So Sophia is sitting right on the end, and she has a mass of 30 kilograms, so her weight is 30g. So that's her there at A. To start with, so the beam is initially modelled as a uniform rod. So the pivot is at the centre. So it tells us that in the question. So the smooth pivot at the centre, smooth means we don't have to worry about friction. So there's going to be a reaction at the pivot, but also the actual weight of the seesaw, which we're not told. Nope, so we're not told the weight of the seesaw. So we'll come on to that. That must mean we don't need it. So we're not told the actual mass or weight of the seesaw. We've got end B, but Roshan is not sat right at the end. He is sitting X meters away from the centre. So he has a mass of 50 kilograms, so a weight of 50g, and he is sat X meters away. Okay. And I want to find what that distance is if they're in equilibrium. Now, there's a bit of a clue on how to tackle this in that they haven't told me the weight of the seesaw. So I can't get the reaction at C, because the reaction at C is going to be that plus that plus that. So if I don't know the weight, I can't say what the reaction at C is. So if I don't know the reaction at C and I don't know the weight, I've got an issue with what's going on there. So basically, the way I get around that is I take moments about C. So there's not really any choice for this question about where you take moments about, because if you took moments about A, you've got two forces that you don't know and you've got a length you don't know. But if I take moments about C, so C is my pivot, then I don't need to know the forces at C, because the distance, so moments of force times perpendicular distance, and the distance is 0. Okay, so if I do take moments about C, I've got two forces there that I'll need to consider. So if you imagine that C is your pivot, this force here, so the 50g, which I think was Roshan, is going to be trying to turn this whole thing clockwise. Yeah, if end B is being pushed down, that's going to be turning it clockwise. So the moment will be the 50g force times the distance from C, which I don't know, so I'm calling that X, okay? And that is the only clockwise moment. Then you've also got this force here. Now, even though they're both going downwards, if you think about them in terms of turning, that force, so if we've got a pivot at C, that force will be trying to turn the whole thing anti-clockwise. Okay, so that's the anti-clockwise moment, which is 30g times the distance. And for this bit, we're assuming the pivot is at the centre. So if the whole rod is 10 meters long, that is going to be 5 meters. It's going to be 5, right? Okay, so the moment there is going to be 30g times 5. So X is going to be 150g, or divided by 50g. So X is going to be 3 meters. Okay, and yet that seems to make sense. So the distance from the centre to B is 5 meters. So he's going to sit 3 meters away from C. That seems okay to me. Okay, so state what is implied by the modelling assumption the beam is uniform. Because that's really just gearing you up for part C, because that's gearing up for part C, because when we stop it, we stop assuming it's uniform. So if it's uniform, the mass, actually not let's just put the centre of mass is at the centre of the beam. The centre of mass works. It's going to put midway, let's be a bit more specific. Centre of mass, I'll get there in the end, right. The centre of mass is halfway along. Are they calling it a beam? Oh yeah, a beam. It's halfway along the beam. Okay, because although we didn't actually use that to answer part A, I suppose you could have just sort of not even worried about that and still potentially got the right answer. Okay, so the centre of mass is working halfway along the beam. Okay, so then turns out that if Roshan does sit 3 meters away, it's not balanced. It's actually got to sit 4 meters away. So now we're saying that it's not. It's just that they realise, therefore, from that it's not a uniform. So it's a non-uniform rod. But to answer this part of the question, we do now need to know its mass. Okay, so let's think about where he's moved further out. So the pivot is still going to be at the centre. Was it Sophie? Yeah, Sophia. So Sophia is still, she's not moving, so she's still there. He is now, so Roshan, we've now established, actually has to sit 4 meters away from the pivot. So let's label in some of those lengths. Okay, so she is still halfway along, so she is still 5 meters. He is now 4 meters. So I can do a quick calculation and figure out which side of the pivot the centre of mass should be. So there will be a reaction. Let's just label in the reaction. Okay. Because his moment is going to be 200 G, her moment is going to be 150 G. So the centre of mass does actually need to be a little bit over to the left there. If you got it the wrong side, it won't matter. You'll end up with a negative length. But for it to be balanced, I can figure that the centre of mass actually going to be a bit over to the left. Okay, and I know that the weight of the beam is 25, well, the mass is 25 kilograms, so I know that the weight is 25 G. Okay, so I'm going to take moments. So the only thing I don't know, actually, what do they want? They want the centre of mass, they want the distance from C. Okay, so yeah, it is that distance there. So that's the distance I need to try and find. So I think it would make sense to take moments about the centre of the beam. I don't have to, there's other options as well, but I'm going to go for that. So, and that's C. So I'm taking moments about C. Okay, so if C is my pivot, that force is going to be trying to turn the whole thing clockwise. So that's going to be 50 G times a distance of 4 meters from C. And that's going to be the only clockwise moment. Then these two are both going to be trying to turn it anti-clockwise. Yeah, if you imagine there's like a pin in it there, it's pivoting there. If you're pushing down on the left-hand side, they're going to push the left-hand side down, which will be turning anti-clockwise. So the 25 G force is a distance of X, and the 30 G force is a distance of 5 from C. So 200 G is 25 GX, it's 150 G, so 50 G is 25 GX, so X is 50 G over 25 G, so a nice round 2 meters. So if we had have put this on the wrong side, so if we'd have had the weight here, we basically would have ended up with minus 2 meters. And as long as you could interpret that as, oh, it must be 2 meters over to the left there, that would be fine. Okay, just check that we did get those answers right. Yeah, 2 meters, centre of mass, midpoint. Did we get 3 for the first bit? Yes, we did, lovely.